Dear students, this is our next problem, and again this problem has also been selected from the book Modern Physics by Kenneth S. Crane. As usual, we first come toward its statement. In a nuclear reactor, each atom of uranium of atomic mass 235 atomic mass unit U releases about 200 million electron volt when it fissions. What is the change in mass? That is delta M. When 1 kilogram, that is 1000 gram, 1 kilogram or 1000 gram of uranium 235 is fissioned. Okay. In a nuclear reactor, each atom of uranium of atomic mass 235 atomic mass units U releases about 200 million electron volt when it fissions. What is the change in mass when 1.00 kilogram or 1000 gram of uranium 235 is fissioned? Dear students, as usual, we first come towards helping tools. Okay, so our first helping tool is just a definition of Avogadro's number. Okay, we are well familiar with this term from our school level physics. Okay, 1 mole of a substance contains Na, where A is for Avogadro's and N is for number. Okay, Na, A is written as a subscript of N. Okay, 1 mole of a substance contains Na Avogadro's number elementary units, usually atoms or molecules, where Na is found experimentally to be Na equal to 6.02 into 10 raised to the power 23 per mole. This is the definition of Avogadro's number. 1 molar mass M of any substance is the substance of 1 mole of the substance. Dear students, this term has been adopted twice in our tools, okay, in order to make our concept more familiar. Okay, in second place there is a conversion table, but I hope we will not need this conversion table. Anyhow, wherever we have to convert electron volt in joule, then this conversion factor, last element, it becomes important. Okay, 1 electron volt is equal to 1.602 multiplied by 10 raised to the power minus 19 joule. Okay, dear students, here 1.602.10 to power minus 19 joule is written, but here dot is taken in the sense of multiplication. I usually use the word capital X or cross in place of multiplication. Similarly, symbol star may also be used for this purpose. Okay, tool number 3, nuclear mass is measured in multiples of the atomic mass unit. 1 atomic mass unit U is equal to 1.66053878 into 10 to power minus 27 kilogram. Okay, here again in place of multiplication dot sign has been used. Okay, This alternatively becomes equal to 931.494028 million electron volt over C square. With the definition of 1U as 1 over 12 of the mass of carbon 12-6 atom. Okay, this is an isotope of carbon. 12 is written as a left superscript and 6 is written as a left subscript of carbon C. Okay. Dear students, in this problem we will use the value of C square in terms of million electron volt over U. Okay. Anyhow, Avogadro's number has once again been adopted. 1 mole of a substance contains Avogadro's number Na elementary units. Usually atoms are molecules where Na is found experimentally to be Na equal to 6.02 into 10 raised to the power 23 per mole Avogadro's number. Okay. Tool number 5. Binding energy of a nucleus with Z protons, N neutrons. Okay. EB, that is binding energy. B is written as a subscript of E equal to Z, M, H is written as a subscript of M plus N, N is written as a subscript of M minus M, left superscript A left subscript Z into C square. Okay. Dear students, here only the thing which is to be noted in this problem, we will take value of C in this manner, that is 931.5 million electron volt over U. Okay, that is to say here we will not take value of C equal to 2.998 into 10 raised to the power 8 meter per second. Okay, in place of meter per second we will take value of C square as 931.5 million electron volt over atomic mass unit U. Okay. Tool number 6 is a typical fission reaction. Okay, this is just in order to fill the formality. Okay. Primarily there is no adequate use of this tool. Okay, anyhow, in order to have some base or foundation for solving this problem, this tool has also been introduced. Okay, now we come towards the solution. Okay, we need to find the number of uranium atoms in 1 gram of U-235, which we find using the fact that there are Avogadro's number Na equal to 6.02 into 10 raised to the power 23 of atoms in 235 grams. Okay, 235 grams. Hence, here number, that is number of atoms, becomes equal to N equal to 6.02 into 10 raised to the power 23 atoms per mole divided by 235 grams per mole multiplied with 1000 gram, because we have to find the value for 1 kilogram, and we know that 1 kilogram or 1000 gram are equal. Okay, so here instead, in place of 1 kilogram, we are using 1000 grams, so that gram will be cancelled out with gram, which is with 235. Okay, moreover, mole will be cancelled out with mole, and this expression, that is number of atoms, will become equal to 0.0256 into 10 to power 26 atoms. In other words, in which we can also write this expression as 2.56 into 10 to power 24 atoms. Okay, dear students, what is the reason for writing this result in this shape? The reason is that I have also many times mentioned that 10 to power 26 is not very important for us. For us, what is important is 10 to power 3 or minus 3, 10 raised to the power 6 or minus 6, 10 raised to the power 9 or minus 9, 10 raised to the power 12 or minus 12, 10 raised to the power 15 or minus 15, 10 raised to the power 18 or minus 18, 10 raised to the power 21 or minus 21, and similarly 10 raised to the power 24 or 10 raised to the power minus 24. That is why here we have converted 10 raised to the power 26 into 10 raised to the power 24. That is why 0.0256 has been converted into 2.56. Okay. Now we move to next step of this problem. Okay, now total energy is the number of atoms multiplied by energy per atom. Okay, that is delta E is equal to 2.56 into 10 raised to the power 24 atoms multiplied by 200 million electron volt per atom. Okay, this is given in the statement. Okay, here atom will be cancelled out with atom and our result will become in million electron volt. Okay, because energy is in terms of electron volt or million electron volt. Okay, hence delta E becomes equal to 512 into 10 to power 24 million electron volt, 512, or we can write it as 5.12 into 10 to power 26 million electron volt. Okay, this is just a conversion. Otherwise, to the extent of 24, our result is more appropriate. Okay. Now we come towards the change in mass, that is delta M. Okay, because we know that E is equal to mc square. So then this implies that delta E is equal to delta mc square. Okay. Change in energy is equal to change in mass into c square. Okay, this implies that from here if we keep delta M on one side, then c square will become denominator and delta E will become numerator. Okay. In the next step, we will put the values of delta E and c square, and here one thing becomes clear that in place of c square we have not used the value 2.998 into 10 to power 8 meter per second. Okay, in place of 3.0 into 10 raised to the power 8 meter per second, we have used the value of c square as 931.5 MeV over U. This thing I have pointed out in two tools. Okay, so we do not here need to go back towards tools. Okay, this value has been repeated in 2 or 3 tools which we have shown earlier. Okay, hence delta M becomes equal to 5.12 into 10 to the power 26 million electron volt over 931.5 million electron volt over, in place of U we have used this value. Okay, because we have also mentioned this value in our tools. Okay, this is not a new quantity. This conversion has been explained in our toolkit. Okay, so delta M becomes equal to 5.12 into 0.166 kg divided by 931.5. This alternatively becomes equal to 0.84992 over 931.5 kilogram. This alternatively becomes equal to 84992 into 10 raised to the power minus 5 kilogram over 931.5. This alternatively becomes equal to 91.24 into 10 to power minus 5 kg divided by 1. Okay. This alternatively can be written as 9.124 into 10 to power minus 4 kg. Okay, it can also similarly it can also be written in terms of 10 raised to the power minus 3 kg. Okay, so this is just a matter of discussion, and this is the final solution of our problem. Okay, that is change in mass. Delta m has become equal to 9.124 into 10 to power minus 4 kilogram, and this is the end of our problem. Till next problem, Allah Hafiz.